So 7.4, we're still dealing with systems of equations, but we're going to incorporate matrices in those. So we're going to learn a new way how to solve systems of equations with matrices. So we have a matrix, which the plural of it is matrices. So down here we have the definition of a matrix. We can state the dimensions of a matrix by saying row by column. So you're not multiplying here, you're just saying how many rows you have and how many columns. Rows, think about it as rows in a movie theater, go side to side. Columns go up and down. And then in the example above here, it says that these are entries. So we list each entry, like if we were looking at this one, it's A with a little subscript of 12, but the 1 stands for row 1 and the 2 stands for column 2. So it just talks about the space that it's in. Like this one would be in row 3, but column 1. So it's not 31, it's row 3, column 1. So that's how we label each entry. All right, so example 1, we have to determine the dimensions of a matrix. So how many rows do I have in A?
1.
1, and how many columns?
1.
So it's a 1 by 1. So quick. For B, how many rows do I have?
4.
1, and how many columns?
4.
1, 2, 3, 4. So it's a 1 by 4. And C, how many rows?
2 by 2.
2 rows and 2 columns. So 2 by 2. And D, how many rows?
3.
3 rows, and how many columns?
2.
2. So it is a 3 by 2. Perfect. And the next one, we have 3 rows and 1 column, so 3 by 1. So the order matters. It's always row by column. All right, so next we're going to be given a system of equations and we can turn it into a matrix. So this is called an augmented matrix. For our column of x's here, we just write the coefficients. So we get rid of the x's, but just keep the coefficients in front. Then we have the y's, so we keep the coefficients. Notice how here I don't have a y. So I would write 0 as the coefficient for that. And then we have the z's, and I write the coefficients of the z's in my augmented matrix. And then lastly, I have the constants, and that goes last. So this is called an augmented matrix. If
What's the yellow? Sorry.
a system of equations,
No, with like the highlight.
this is the constants. Like what it's equal to. So if I were to just write a matrix with the coefficients, that would be our coefficient matrix. And then if I were to just write a matrix with the constants, that would be the constant matrix. All right, so looking at example 2, it says write the augmented matrix for the system of linear equations. So there's a couple different ways we can do this when writing our matrix. We can either take it column at a time, so we can write all of the x's in our first column, all the coefficients of the y's in the second, then all the coefficients of the z's, and then the numbers. Or we can take it 1 row at a time. So starting with the first equation, what's the coefficient for x? 1. What's the coefficient for y?
3.
And what's the coefficient for z?
None.
None, so it would be 0. And then our constant's 9.
That line is representing, what is that line there?
Like how up here it had dots, you can just put a line. It represents like the equal sign. So then in our second equation, what's the coefficient for x? 0. The coefficient for y? -1. And the coefficient for z? 4. And our constant? -2. And then in the third equation, what's our coefficient for x? our coefficient for y,
0,
and our coefficient for z,
0, 5,
and our constant
0.
0. So this would be our augmented matrix. And then what are our dimensions for the augmented? Perfect. So we have 3 rows and 4 columns, so it's a 3 by 4. All right, so we're going to continue 7.4 from Friday. We know how to identify the dimensions of a matrix. Now we're going to be solving systems of equations using matrices. So we can perform these operations with matrices. We can interchange 2 rows. We can multiply one of the rows by a non-zero constant. And then we can add a multiple of one row to another row.
So a non-zero constant is
Any number except 0.
why not 0?
Because if we multiplied one of our rows by 0, it changes everything in that row to be 0. So it gets rid of the whole row, which we don't want to do that. So this here is called row echelon form. We're going to put our matrices into row echelon form. So our goal is to have a diagonal of 1s and then 0s underneath. So we're going to have 3 1s and 3 0s, and then the rest of it will be numbers. Once we get it into row echelon form, there's going to be other numbers on the other side. So we can say that this would be like 4, 5. I just made random numbers up here. Like this. We'll have some numbers on the other side of it. Once we get it into this form, we can plug it back into our variable equation. So our first row would be x plus 4y plus 5z equals 2. What would the second row be? Y plus 3z equals 6. And what would the third row be? Z equals 2. How could I solve for x, y, and z from here? I would use back substitution. So I'd plug in z into the z's, and then I would find y and plug in y into the y. So from here, we use back substitution.
If you lose 0, because it goes alphabetical, just like x, y, and z. If you lose 0, you don't pay anything, right?
Right. So our goal is to put it in row echelon form and then use back substitution to solve. So the first couple examples, the first one just wants us to do one step at a time. So for example, 3a, it says interchange the first and second rows of the original matrix. So we can change the order of the rows if we wanted to. So here we're just going to flip the first and the second. So I'm going to make the second row my new first row. So this is -1, 2, 0, and 3. And then I'm going to make the first row my new second row. So 0, 1, 3, and 4. And then the third row stays the same. 2, -3, 4, 1.
Wait, what are you doing?
Interchanging the first and second rows.
No, you can do anything, but you don't have.
Okay, and B, it says multiply the first row of the original matrix by 1/2. So we're multiplying this by 1/2. So again, we ideally want a 1 to be in this spot here. So we can, if we have a number other than 1, we can multiply by some number to change it to be 1. So we multiply by 1/2. This gives us 1, -2, 3, and -1 in our first row. And then the other 2 rows stay the same. So 1, 3, -3, 0, 5, -2, 1, and 2. So in C, it says add -2 times the first row of the original matrix to the third. So I'm adding two rows together. I'm adding -2 times the first row. So -2 times row 1. And I'm adding it to the third. So row 3. So I'm going to do the math on the side here, but rewrite my matrix down here. So -2 times row 1, multiplying this times -2, that becomes -2, -4, 8, and -6. And then row 3 is 2, 1, 5, negative 2. And I'm going to add these together. Where do you think, bless you, this is going to go when I add them together? In which row? The third row, because I'm adding to the third. So it'll go in the third row. So rows 1 and 2 stay the same. I have 1, 2, negative 4, 3, 0, 3, negative 2, negative 1. And then my new third row is going to be what I get here when I do the math. So this will be 0, negative 3, 13, and negative 8. So that's my new third row. In example 4, it solves it for us. So it's comparing a linear systems and a matrix operation. So here's our linear system. They change it to be the augmented matrix. And then in each step, they wrote out what they're doing. So they added row 1 to row 2 to get a 0 in this spot. Then they added negative 2 times row 1 plus row 3 to get a 0 in this spot. So you always want to work with the first column first. So this is step 1. Then you go to the second column. This would be step 2. And then you want to get a 1 here, and that's step 3. So always work with the first column first. We need 1, 0, 0. Then this could be any number, but we need a 1 in this spot and then a 0 here. So remember, we need a diagonal of 1s, so it'll look like this. 1, 1, 1, and then zeros below it. And then some number above. And numbers as our constants also. So this is our goal. So that's what they did here. They got a diagonal of 1s and zeros below it. All right. So our next example, we're going to be solving. So we want to get a diagonal of 1s and zeros below it. So our goal is to get 1, 0, 0, some number, 1, 0, a number, 1, and then numbers on the right side.
Isn't that only for row echelon?
For row echelon form.
Just asking for option.
So we're going to put it like this and then use back substitution to solve. All right, so my augmented matrix is going to have what for the first row? What are my coefficients? Negative 1, 1, negative 1, and negative 14. What's the second row? 2, negative 1, 1, and 21. And the third row? 3, 2, 1, and 19. Well, let's do it. So step number 1 is to make this a positive 1. So I'm going to multiply my first row by negative 1. So my new first row is going to be 1, negative 1, 1, and 14. And then the second two rows stay the same. 2, negative 1, 1, 21, 3, 2, 1, 19.
Then you can add the weight.
So step 2
Do you have the first one and the third one?
is to get this to be 0.
I added the first and second one, but I multiplied the top one by -2, so it cancels.
Perfect. So we want to multiply the top one by negative 2. So negative 2 times row 1 plus row 2. Because we know if we multiply this number by negative 2, it'll cancel out with that, and we'll get 0. So multiplying the first row by negative 2 gives us negative 2, 2, negative 2, and negative 28. The second row stays the same, so that's 2, negative 1, 1, and 21.
So then it's 0.
Our first row stays the same. And then whatever we get here is going to be our new second row.
0, 1, -1, -7.
Perfect. So So their new second row is 0, 1, -1, -7. Third row stays the same. So I have to now move on to this spot. So what can I do to make this 3 a 0?
Multiply the first one by -3 and add.
Perfect. Multiply -3 times row 1 and add it to row 3. So -3 times row 1 would be -3, 3, -3, and -42. And then the third row stays the same when we add it here. So it's 3, 2, 1, 19. First two rows, nothing's changing. I'm rewriting that because my goal is to get this to be a 0. So I'm only changing the third row. So the first two rows stay the same.
Oh, so you just keep multiplying each row by something to get that form in the beginning that you want it to get?
I'm multiplying a row by something and adding it to another row. So I'm multiplying -3 to get this to be a -3, so it'll cancel out with the 3 down here.
You keep adding it with the same row.
Yeah, so like I used row 1 in the green, and I used row 1 again in the yellow. All right, so when I add these together, I get 0, 5, -2, and -23. So this is already a 1. So I'm good there. Next, I want this to be a 0.
Multiply the top one by 5.
If I multiply the top row by 5, what do I get here? A 5. And what's 5 plus 0? 5. So that changes that number, which we want it to be 0, to be 5, which is not good. So what else can we do?
Oh, the second one.
Multiply the second row by -5. So I'm multiplying -5 times row 2 plus row 3. So when I multiply this times -5, I get 0, -5, 5, and 35. Row 3 is 0, 5, -2, and -23. So my first two rows are staying the same. I have 1, -1, 1, 14. And 0, 1, -1, -7. My new third row is going to be this. So 0 plus 0 is 0. 5 plus 5 is 0. And then 3, and then 12. So now I need to make this a 1. I can divide by 3 or multiply by 1/3. Same thing. So the first two rows stay the same. I have 1, -1, 1, 14, 0, 1, -1, -7. And then I'm going to multiply this by 1/3. So 0, 0, 1. And what's 12 times 1/3? 4. So here I have a diagonal of 1s and 0s below it. So once I get to this step, I can plug it into my variable equation and solve using back substitution. So what would my first equation be? X minus y plus z equals 14. What's my second equation? Y minus z equals -7. And my third? Z equals 4. So this is row echelon form. This is part of your answer. You have to get to this step to then plug it in here. The second part of the answer is to actually solve for x, y, and z. So what can I do to solve for y? Because I already have z. Plug in z into the second equation. So I have y minus 4 is equal to -7. Add 4 to both sides. Y equals -3. And then what's next? Plug in y and z into the first equation. So x minus -3 plus 4 equals 14. x plus 3 plus 4 equals 14. So x is equal to 7. How do you think I write my answer?
7, comma, negative 3, comma, 4.
7, negative 3, 4. So we're going to do the same thing here. What is my augmented matrix? What's the first row?
1 minus 2,
1, negative 2, 3, 9. The second row?
9. Negative 1, 3, 1, negative 2,
And the third row?
2, negative 5, 5, 17.
Perfect. Now step 1 is to always get a 1 in this top left corner. So we're already good there. What do I want to do next?
Get a 0 in the second.
Get a 0
So add the first and
here. So I can add the first and second. Perfect. So I'm going to add row 1 plus row 2. So 1, negative 2, 3, 9, negative 1, 3, 1, negative 2. This is going to be my new second row. So rows 1 and 3 stay the same. My new second row is going to be 0, 1, 4, 7. So
By negative 2.
to get 0 here, I can combine these two equations together, but I have to get this one to be a negative 2. So multiply negative 2 times row 1 and add it to row 3.
To get what? What are you trying to get?
A 0 here. Because I want to work in columns first, so get 1, 0, 0, then a number, 1, 0, then 1. So my goal is to change this 2 to be a 0, so I'm going to multiply negative 2 times row 1, so negative 2, 4, negative 6, negative 18. And row 3 is 2, negative 5, 5, 17. Rows 1 and 2 stay the same. And then whatever I get here goes into row 3. So negative 2 plus 2 is 0. 4 minus 5 is negative 1. Negative 6 plus 5 is negative 1. And negative 18 plus 17 is negative 1. All right, so I'm good with the first column.
R2 plus R3.
Next, I want to add the second row and the first row because my next step is to get this to be 0. I already have 1 in the middle here, so then I want right below it to be a 0.
So second and third.
So add the second and third. So row 2 plus row 3.
Changes one of your things that you needed.
So the first 2 rows stay the same. 1, negative 2, 3, 9, 0, 1, 4, 7. And I'm changing the third row. So row 2 plus row 3, 0, 1, 4, 7, plus 0, negative 1, negative 1, negative 1. Add these two together. I get 0, 0, 3, 6.
And then now you just multiply the last one by 1/3.
Perfect. I'm going to multiply the last one by 1/3.
Wait, but what are you missing? Yeah.
I want this to be a 1 now. Because I need a diagonal of 1s and the 0s underneath. So I need to change that 3 to be a 1, so I'm going to multiply by 1/3. So the first 2 rows stay the same. And then the third row is going to be 0, 0, 1, 2. So I have this set up the way I want it to. I have a diagonal of 1s with the 0s underneath.
The other numbers could be anything, right?
The other numbers above can be anything. So what do I do next?
Now put it into your
Put it into my equation with variables. So what's my first equation going to be?
x minus 2y plus 3 equals 9.
X minus 2y plus 3 equals 9, plus 3z equals 9. So this is my column of x's, this is my column of y's, this is my column of z's. What's my second equation? y plus 4z equals 7, and z equals 2.
So you're just plugging it onto the original equation.
And then from here, how can I solve?
Substitution.
Back substitution. So plug z into z. So I have y plus 4 times 2 equals 7. Y plus 8 equals 7. Subtract 8. Y equals -1. And then plug that into the first equation. So I have x minus 2 times -1 plus 3 times 2 equals 9. And then solve. So x plus 3 plus 6, no, x plus 2 plus 6 equals 9. X plus 8 equals 9, so then x equals 1.
So 1, comma, -1, comma 2.
So our answer would be 1, -1, 2.